Hello, and welcome back to the next in our series of beginning Java tutorials. We've learned a lot up till this point, but today is a day when we have to make a really important leap. You might recall in a previous lesson I mentioned the famous mathematician Dijkstra that said that in a structured programming language you need to have three things. You need to have the ability to do things in sequence. Well, check, you've done that. You need the ability to make decisions. So conditionals, well, check, you've done that. You've learned if statements and switch. And the third thing is you need to be able to have some sort of repetition in there. And guess what you're about to check off today? It's the repetition piece. In programming, when we speak of repetition, what we're usually referring to is this idea of loops. If you're writing pseudocode, you'll actually often use the word loop, even though very few programming languages actually use that terminology. But the idea of a loop is that you have a series of a sequence of code that you can repeat. And you can repeat any number of times depending on the conditions that you set for that loop. In very old programming languages, there was a very simple form of a loop, which was a goto statement. And a goto statement would allow you to do a bit of decisions and loops in that you could jump around to different parts of your code. Go to line 10, and you could always have a piece that loops around, continually going back to line 10. And that was a very old way of managing it. In most modern programming languages, we have a little more nuanced way of being able to make these decisions. And it turns out that Java, like many other programming languages, they kind of divide decisions into two distinct categories. And so on the one side here, we have what's called counted loops. And this is an example of this would be, I want to loop through this piece of code 4 times. Imagine you're trying to make a square. If you've ever done those code.org things and you're trying to make, Elsa make a little square in the ice or something. Well, what you do is you might say, make a line and turn right, and do that 4 times. Make a line, turn right, 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 and then there you go, you've got a square. That's an example of a counted loop. Sometimes it might look like repeat, repeat 8 times. In Java, the word that we're going to use is for. It's called a for loop. It's going to do something for 8 times, as an example. The other type of loop is what's called a conditional loop. And with these type of loops, what you're doing is you don't know if you're going to be looping once or twice or 1,000 times. What you're doing here is you're looping as long as some condition is true. So if you think about a game that you're playing, you might have a loop that says, keep going while my health is greater than or equal to 0. So as long as my health is greater than or equal to 0, keep playing this game, and then when it reaches 0, that's it. You exit that loop, and it's game over. So there's 2 distinct ways of doing these types of loops in Java, and we're going to break them up into 2 distinct lessons. And the lesson we're going to look at today is the counted loop, being able to do things a certain number of times. And it turns out that this is actually going to be a little bit more complicated than the conditional loop, which is going to feel a little bit easier when we learn it. So, I'm a big fan of getting the hard stuff over with quickly. So we're going to jump into this one first today. So, the for loop. The best way to think about the for loop is you're going to create a structure that is going to do counting. And it's going to count a certain number of times. And every time it counts, it is going to run through a set of statements. And so even though when we talk about counted loops, we're saying, it's going to go 8 times. In Java, you don't think of it necessarily as 8 times. Think about it as starting at some number and counting a certain number of times and then ending. That's the way the structure of the for loop goes. It has a starting condition. It has a step, which is the going up each time. and then it has a condition that tells it to keep counting. And so let me give you an example of what this looks like in Java. So the for loop has a new keyword for you to learn, which is called for, oddly enough, and it's going to have 3 distinct parts to it. And it's important that you really understand each of these distinct parts individually. And you'll see that they're separated by semicolons. So here I've got my first part, here's my second part over here, and this would be my third part inside there. 3 distinct parts. Now, this first part is what I like to call the starting position. So what this is doing, oh, that is definitely not very good. Starting position, and this over here is what I like to call the continue position, and this over here is the step. Start, continue, step. So let's see what each of these mean. So the start is basically saying, where do I want to start counting? In this case, I want to start counting with the variable I, because if you want to keep track of your counting, you need some sort of a variable to do it. So variable I is going to do my counting, and we are going to start counting at 0. Pretty easy. This could be any variable that you want inside here. It doesn't have to be I. Very often programmers will use I and J to keep track of it as they go through, but it could be anything really that you want. You can declare a new variable like I've done inside here, or you could use a variable that already existed and you could just give it a starting value in here if you want. Then what I have is my continue condition, and beginner programmers, this is probably one of the most confusing parts, is it's not telling me when to stop, it's telling me to continue counting as long as this Boolean statement is true. So keep counting as long as I is less than 10. And then this last piece, I put in a bit of shorthand in here, which, remember, this is shorthand for I equals I plus 1. This is telling you how to count by. So, go back to grade 1, count by 1s, count by 2s, count by 5s. Normally, when you have a counted loop, you want to just count by 1s, and that's what this is doing. And so everything that's between the curly bracket here and the other curly bracket that I would have at the bottom, everything in between those 2 spots is going to run in a loop. So let's say that I add a little bit more. Let me just bring in a new bit here. Let's add some more details. And inside here, I say c.println hello. And then I end my curly brackets. So the first time I come into this loop, I becomes 0. And it's going to run through, it's going to do the check. It's going to say, is I less than 10? No? Yes? Maybe? Yes, it is. So it's going to come through here. It's going to print hello once. Then it goes back up to the top of the loop. It increments I. So instead of being 0, it now is going to become 1. Is 1 less than 10? Yes, it is. So it's going to print hello again. And it's going to keep doing that. 2, 3, 4, 5, 6, 7, 8, 9. When it hits 10, it will break that condition. So it will not print hello, and then it will come and do whatever is underneath here. It'll basically exit that loop and start with its conditions. Remember, just like with strings, we're counting usually starting at 0. It's important you get into this habit. You could start counting at 1 if you wanted to, but there are so many things that you start at 0 in programming that you really need to get into the habit of starting your loops at 0. It's a lot easier. So even though this is less than 10, it is going to run 10 times because it's going to go from 0 to 9. So you got to get into that habit a little bit. Remember, this is just using this variable I is just being used to help you count. I can use it in my code if I want. So I could print line just I, and now what's going to get printed to the screen is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. and that's it. Okay, so 3 different parts you've got to keep track of: the starting condition, the continue as long as this is true, and then the step. Now, to show you what happens when you change these, to manipulate them, I think we need to jump into Java a little bit so you can actually see the results of what we're doing. And voila, like magic, here we are in NetBeans. We're using this console helper class again, and so let's get into the for loop. So what have you learned so far? Think carefully now. The key word to identify this type of loop is for. The very first part has to give you a variable that you're going to use to count and where you want to start counting. The second one says what condition you're going to continue looping or continue counting for. So I want to do it 5 times. And then the last thing is what your step is. And so I want to count by 1. Notice that I don't put a semicolon, just like the if statement. This isn't really executing code as much as it's creating a block of code that's going to happen. So what I'd have to define is that block of what's going to happen, and everything between these brackets is going to be within that loop. So inside here, I'm going to print to the screen. Actually, let's just use a print statement, I with a space, and this will help you visualize what's happening. It is going to start counting at 0, and it is going to go all the way to 4. It is going to count 5 times. And I hope you can see why it's important to start at 0. Let's say you wanted to loop through a string and you wanted to get each individual character of that string. Well, remember what we said about strings, they start at position 0. And so it's important that you get into that habit of starting there. Now, let's imagine that instead of 4, I start at 7. And it's important you understand the sequence of what's going on here. So Java is going to come here. The very first thing it's going to do is it's going to set up a variable I and set it to be 7. The second thing it's going to do is it's going to check the condition. In this case, it is now false. I is not less than 5. Therefore, it is going to skip over this code entirely, and it is going to run whatever I put here. So let's just print here, and we run this code, and you will notice that it did not run the loop at all. So order is important. First thing that Java does is set up the variable, the starting condition, then it does its check. Then it runs whatever code is in here. It goes back up to the top. It increments. It checks. Does the code. Increment, check, does the code. And it keeps repeating that over and over again until the condition here is met. What happens if the condition is never met? What if you make a mistake in here? And let's say you say something like I is greater than -2. In this case, what you've done is you've created a loop that is potentially, but not truly, infinite. And if I run it, it is just going to keep going and going and going and going. Now, numbers, as you know, in Java are defined in a particular number of bytes. And so at some point, you're going to reach the end and you're going to loop back into the negative numbers. But you have to be very careful with your conditions here to make sure that at some point is going to end. So you have to be very careful with your signs and how you're using them. So let's put something else back in here, and now let's focus on this last part. 90% of all of the programs I've ever written, I go up by 1 or I go down by 1. So I can have I++ to go up by 1. I could have I minus to go down by 1, but it is possible for you to go up by whatever you want, right? This is just a step, so you can use that step however it is that you like. And what you will notice is that by changing the step, I'm changing the number of times that I'm going through that loop. So now I'm going through at 0, I'm going through at 3, 6, 9, and then when I get to 12, I've broken the condition so it doesn't execute. So this is the anatomy, the three main parts of a for loop, and you really need to get comfortable using them. You don't have to define a variable. I could have a variable set up here, and I could use that variable inside here without actually defining it. Why would you want to do one versus the other? Well, if I wanted to print that variable at the end for some reason, I would want to define it up here, because in the past we talked a little bit about scope. And so remember that if I were to declare a variable here, this variable only exists for this for loop. As soon as I leave the for loop, look, I've got an error here. It's saying there ain't no I here. So if you ever want that variable used later on, you're going to have to declare it outside as opposed to inside. Same thing with any variable that I create inside here. Because it's within a particular scope defined by those brackets, I cannot use that variable outside because it only exists within this particular scope. Now within these brackets, I can have whatever code I want inside here. So, I could easily put in an if statement. So now what's going to happen is, let's just bring this back to 1, and let's run this wonderful code. Oops, I got to actually fix the mistakes I purposely made. And now you'll notice that what's being printed here is only 4. And that's because you can have any sort of code that you want inside there, including an if statement, which is now saying only print something if I equals 4. One of the tricky things is that you can also have what's called nested loops, which means that I could put, if I wanted, a loop inside a loop. So let me give you an example of that. I need to have a different variable to do my counting, right? This loop, this I is counting for this loop. If I want to create another variable, another loop, I need to use another counter, or else the two are going to conflict with one another. So I is often one, j is often another. Let's make it, there we go. And now anything that I put inside here, let me just put in those brackets to sort of help you see, is now what I do is anything I put inside here, is going to happen in this middle inside for loop. So take a second now, pause the video, really pause the video, and I want you to think about how many times you think this line of code inside here is going to run. Think about it. Pause. Okay. So hopefully you're back now and you thought about this. Now, a common answer that comes out of students is 20 times. This is going 10 times, this is going 10 times. It has to be running 20 times. But what you have to remember is that this is nested. This code is happening inside here, which means, well, let me actually just show you what it means. Let's put I. Let's leave a little bit of a space. And let's put j inside here. And what you can see is happening here is that when I hits 9, just one number, this is going to happen 10 times. That means when I is 0, j happens 10 times. When I is 1, j happens 10 times. When I is 3, j happens 10 times. So what you're actually getting is multiplication happening here. So this, whatever you put inside here, is going to happen 10 times 10 times, or 100 times is what's going to happen here. If I put something here, this is not inside this inner loop. It's just out here, which means it's only going to run 10 times, which means that here it's going to print this 10 times, it'll print this once. Then it'll come back, it'll print this 10 times, it'll print this once. So you have to really be careful when you start to have nested loops like this. You have to be really careful of where you're putting things to think about what your scope is. Again, I can't print J out here because J is only existing in the scope of that one loop. Lots of reasons why you might want to have nested loops. When we start to think about tables, you're going to see why when you want to go through a table, you really have to have a nested loop to help you do that. So that's some of the tricky aspects of loops. There's just a couple of other little nuances, really tricky things that I want to talk to you about. There's two key words that are used in loops which you're going to find helpful at some point. Not as helpful for counted loops, but a little more helpful with conditional loops. And I'm going to introduce them here, and then I'll introduce them again later when we talk about conditional. And one of them is a command called break. The key word is break. And the idea is that, yes, I have a loop. Yes, it's counting 10 times. But what if I just want to exit early for some reason? Maybe I'm getting input and I want to get 10 pieces of input from the user, but if the user does something wrong or if they enter in a certain number, then I want to be able to exit. And so the key word for that is break. And it looks like this. And whenever Java encounters a break command, it is going to exit out of whatever structure it's in. Whatever kind of for loop it's in, whatever loop structure it's in, it's going to completely exit out of that and start down here. So for example, let's put in that print line again. Well, we don't want that in quotes. Let's run it. And oops. Unreachable code. Yeah, okay. It won't even let me test that. So let me put this over here. So look at what's happened here. Because I have this break command here, what I was trying to demonstrate to you was that this line of code will never run because as soon as it comes into the loop, it's going to exit the loop right away. So Java was a little bit too smart for me. But what I could do is I could put this above the break. And even though it looks like this loop is running 10 times, it's only going to run once and it's going to exit prematurely. Now, you wouldn't normally use it like this. What you would use it with is some sort of an if statement, some sort of a decision, you know. If I is equal to 4, then I want to break. And so now what we've got is the same sort of idea, but it's going to go 0, 1, 2, 3, 4. And then when I becomes 4, it is going to break and exit that loop, come down here and print the end. So that's really neat. There's another one that's a little harder to explain. It's called continue. And the continue command basically means stop executing the loop here. Stop executing this iteration or this time through the loop. Go back up and start with the next one. So let me sort of run you through this really quickly. You're going to notice 4 is missing. But instead of exiting and coming down to the end, it continued to execute the loop with everything after 4. So what happened here was when it became 4, it met this condition, it continued, which means that it skipped everything else in the loop, went back up, turned it into 5, did its check, and then came through here again. And so continue is basically just a way to say, just stop this iteration of the loop, don't do anything else under there, loop back up and continue with whatever is left inside the loop. So we're almost there. The only thing that I want to highlight is, remember we talked about the brackets, and you'll notice here that when I did this if statement, I kind of left out the brackets, and the rule for an if statement was that if you don't have these brackets here, the only thing that belongs to the if statement is the very next line. And I said that can get a little bit confusing because, you know, especially when you don't have your tabs set up properly, it's really easy to get confused and to think that both of these are going to be run with that if statement, which is why I said to always use your curly brackets there. The same thing goes with loops. You can have a loop without the curly brackets inside it. It is possible to do that. But the only thing that's going to be executed is the very next block of code that comes through it. So that's why you'll see that right away I got an error here with this I, because now this loop is only going to include this one block in front of it, and this is actually considered to be outside the loop. So again, with for loops, always use the curly brackets, because Java isn't necessarily going to say something is wrong if you don't have them when it might be. So get into that habit. So wow, we've covered a lot. You now understand that there are the idea of repetition in programming. You understand that there's two ways of doing that in many modern programming languages. And today we focused in on the idea of counted loops. We explained the for loop. We explained the key parts, the 3 parts of a for loop, and the differences between them and why it's important to really focus in and understand them. And then we got into a whole bunch of complex topics with those loops, like how to break out of a loop early, how to continue, to stop that iteration and go to the next one. We talked about how loops could be nested within each other. And then just now we talked about what happens when you don't use your braces or brackets with that. It takes a lot of practice to use for loops properly and to not get confused. And so that's one of the things that you should be doing right now, is if you're following along in the course, to go through those lessons and to really understand the different parts, to use them in different ways. You've got to write lots and lots and lots of loops, because as a programmer, no matter what language you're in, you're going to be writing them. So take some time, get used to them, and I'll see you in the next video.